Welcome to the microengineering courses. So today we learn that a semiconductor laser, that semiconductor laser, that in a semiconductor laser, a stimulation emission takes place. So that's why that device is called a stimulated emission device. Generally, there are two types of stimulated emission device. One is about a laser. Okay, so I'll stop. Okay, so one is about a laser, and another is about a maser. Laser means what? A light amplification by stimulated emission of a radiation, and a maser is means what? That is a micro amplification by stimulated emission of a radiation there. Now, if you see that lasers and a maser, that input is different, we say, but the action takes place here, we say stimulated emission of a radiation. Here in light amplification is there takes light amplification takes place and micro amplification takes place. Okay, there are about the two different types there. So now we can we'll see that what happened to the laser. Generally, we say that a laser produces a narrow beam. Okay, or we can say that laser produces a very high, that is about very high, or we can say that is about generally a coherent visible light, or you can say that it's monochromatic light, or you can say that it's about the narrow and intense visible light. So that is about your laser. And laser, why we are learning a laser in a microwave? Because we are using this laser at a micro frequencies, we say, and we supposed to know that that lasers are used for in a medicals and all. Okay, applications of a laser that we are learning here. So that's why we are going to learn that laser there. And because we need to learn about the mesers, okay, because the mesers, if you see that meser, it produces a similar beam of invisible microwaves. Okay, that beam in a laser is same in a mesers there, but it is about the invisible microwave. And again, if you see that, need to log may not. Okay, maybe people are here. Okay, so they may have joined. Right. Okay. Now, now you consider that if you consider the lasers and emission, so in this both the cases, that number of excited molecules in some medium that will be increased by what? A population inversion, and a micro or other electromagnetic waves of same frequencies that will be incident on them. So this is about a light we consider here. That is about a coherent light. We say that is about a it that is about a laser uh, works or mechanism in a laser, that is about a spontaneous emission and a stimulation emission. Now, if an incident photon, okay, if an incident photon is energetic enough, it may be absorbed by an atom, raising the latter to an excited state. So, how that electron raises to the excited state, that we will learn here. Now, that we need to know about that characteristics of a laser. So, it emits a high power. So that's about it has a continuous wave. So that's why high power. Your signal is a coherent one. So that's why you can say that's about we are able to get the high power signal. Then a direction, or we can say that is about the output pattern of this LED, or we can say laser, is a it depending upon that which material we are going to be used there. And generally we have seen that in a optical fiber, that lasers or LEDs, they are allowed to permit for the single mode fiber or a multi mode fiber. Likewise, so similarly, these lasers we can use as a transmission line as a fiber there, and generally we are preferring a single mode fiber so that we will get that high power output there. And all these devices, they have a narrow spectral width. So if you consider that laser or a laser, okay, that is beam is narrow. But if you consider that a LED, that emission pattern of a LED is different. Okay, uh, the emission pattern is different, means we are getting the output. Okay, we are getting the output that is emitted in a one direction there. That is for the LED. But we need to design a device in such a way that it will produce a narrow beam output there. So for the LED there. So generally a laser diode, it is just like a device that is about a p-n junction device here. And here we say that laser diode is a semiconductor optical amplifier, and it has an optical feedback. And a optical amplifier, that is again a forward bias, and it is a heavily doped p plus n plus okay junction. This one is about a, we can say it is about a heavily doped there, and it injected a current that is sufficiently large to provide the optical gain. So that's where we are saying that laser will work as a amplifier there. So that refractive index difference between the crystal and the surrounding air causes the cleaved surface to act as a reflector. Means this is about a junction, a small material or small surface we say, and from this particular surface we are getting the output. So that's why we say that is about when your light emits from the material, so that refractive index of that material surrounding to the component that we need to be know there. Okay, am I audible? Hello.
Yes, sir.
Okay, so something. Okay, so because it is showing the message most of the time network issue. Okay, let it be. If supposed to be at moment in time, you're not able to see that. You can mention me. Okay, inform me. Next about it, we see that is about it has a so, that it works in the base of we can say that is about a spontaneous emission and a stimulated emission. Okay, so we'll go ahead here. So that we learn about the spontaneous emission. So spontaneous in a spontaneous emission, we can say that electron can drop back spontaneously to the ground state, and we learn that through this particular diagram how that emission takes place. So that is about we say that we have the electrons in a ground state or excited state. So we can say that is about the emission from the laser. It takes place. We have the emission. So we need to learn about that how that electron uh, emitted from this particular state there. So when we say that emitted photons, we say that each electron